Select the statement that best describes the reaction below at equilibrium. And so we can see what we have is an acid-base equilibrium. So when we're deciding what this looks like, we know that this reaction will tend to flow in the direction that will form the weakest acid and the weakest base. So this will form the weaker acid and the weaker base as the dominant species once this reaches equilibrium. And another way of stating this would be to say that it favors a particular side of the equilibrium, saying you would have more products if it favors the products, more reactants at equilibrium if it favors the reactants. And so to compare, we want to look at acid strength. And so we've been given pKa values. So by this pKa value, that helps us to identify that this acetylene molecule is the acid, which means the sodium hydroxide that it's reacting with is the base, and it's really just the hydroxide ion that's the base. So we'll draw that out as the base. The sodium is there, but that is a spectator ion. And we will see this quite often in organic chemistry, that these alkali metal cations, we'll see them present a lot, balancing the charge on an anion, but not involved in reactions. So you'll see a lot of sodium and potassium just kind of being spectator ions. Okay, so this is our base, this is our acid, and then we can say, okay, after this acid reacts, if it's acting as an acid, it's losing a hydrogen, and what it's forming is going to be the conjugate base. And after your base has gained a proton, so in this case, when hydroxide gains a proton, it becomes water, and this is the conjugate acid. So now we have everything labeled. We can compare and find where we have the weaker acid and the weaker base. And we were given pKa values here. So this is actually very, very straightforward. So we know that with a pKa value, the lower it is, the stronger the acid. So we can just directly compare the numbers that we have here. So we see water with a pKa of 15.7 compared to this acetylene with a pKa of 25. This tells us that water is the stronger acid, which therefore means that the acetylene is the weaker acid. And we can go through and label everything. Your weaker acid and your weaker base will always be on the same side of the equilibrium. It's not possible for it to be any way, so any other way. So we can stop here now that we have the weaker acid and we see that the reactants are favored. This is not a reaction that's going to proceed towards products. But we can go through and label everything. So the stronger the acid, the weaker its conjugate base. So that's why your weaker acid and weaker base are always going to be on the same side. So if you've found your stronger acid, its conjugate base is the weaker base. And the opposite relationship also holds true. When you find your weaker acid, its conjugate base must therefore be the stronger base. So the side of equilibrium that's going to be favored is definitely this reactant side. And then we just need to find the statement that accurately describes what we have up here. So we can see only C and D talk about favoring the reactants, and D says that water is the stronger acid than acetylene, which is true. So this is the right answer.